Welcome to today's GATE coaching video session. I am Savija from AADS department in SA Engineering College. My topic is classification in supervised learning. Before going to the supervised learning, we are going to learn the machine learning. What is machine learning? The machine learning is a subset of AI. It is an enabling system to learn the patterns from the data. It uses the algorithms, machine learning that uses some algorithms to identify the patterns and make decisions and predictions. Example, spam filtering, recommendation system and self-driving cars. In machine learning, one type of machine learning is supervised learning. The supervised learning that will be learns the patterns from the labeled data set. For example, the input, that is input and the correct output data. The data set that having the input data and as well as the correct output data. That correct output data that is called as the labels. Okay, that will be map the input function, input data set with their predicted output. That input data that having the input as well as the output, based on that will learn something that is called as the patterns. Based on that patterns, that will give the output for the new data set. That is input data set, that is the features and attributes of the data set, and each and every attributes that having some labelings. That based on that labels, that will be find out the new patterns. The algorithms, machine learning or supervised learning, that having lot of algorithms. Using that algorithms, the data set will be trained. Every trained data set, after that it will identify one pattern. Using that patterns, that is a XY pair pattern. Based on that patterns, you will predict the new data set. Supervised learning steps. For example, spam or not spam. The particular given email is spam or not spam. How to find out? Okay, the first one is data collection. Every data set that having a emails, that emails labeled with if the particular email is spam or not. It is the input. Every emails that having the labels, either spam email or not spam emails. Okay, based on that data set, you have to extract the features from the emails. Every emails that having some features, based on that features, every features that will be labeled with the labels. Okay, convert the text into numerical values. Based on that numerical values, like word frequencies and TF-IDF, based on that it will extract the features that will be mapped with the labels. Based on that labels, you have to train the machines. After the training, for example, classifiers, we are using naive based classifier. Like that, you have to, this is the one algorithm. Using this like this algorithms, you have to identify the patterns. After that, testing, you will find on new pattern. For this pattern, you have to give the another one new input. Based on that unseen emails, you have to given to the patterns that evaluate the accuracy. If the new email is or unseen email is spam or not. The prediction is classify a new email. The new unseen email is spam email or not spam email. Okay, the next, so in supervised algorithm, that having two types. The first one is classification and another one is regression. In classification, it predicts the categorical data, categorical values. Like example, email spam detection, and it uses some algorithms, logistic regression, SVM, decision trees and neural networks. The second one is regression, that is predicts the continuous values. In classification means that predicts the categorical values. It is yes or no, true or false, like that. Prediction means that predict the future values. The algorithms are linear regression and polynomial regressions. The next classification that predicts the discrete or categorical outputs. Okay, the classification that having three types: binary classification, multi-class classification, and multi-labeled classification. Binary classification means if the email is spam or not. The multi-class means digit diagonalization. So among the digits 0 to 9. Multi-label, multi-class, among many classes it will select one class. Binary classification means among two classes from select one class, but multi-class classification means it selects one class among the multi-classes. Okay, multi-labeled classification means the particular data that fall multi-labels, the particular class, the particular category that will fall some under the multiple labels. Binary classification, there is two possible classes. One binary classification that having only two possible classes. From the two possible classes you have to select only one class. That is example, spam mail. If the unseen emails, if it is comes under the spam mail or otherwise comes under the not spam email. Okay, the next one is multi-class classification. That will be identify the class from the number of classes. That means handwritten digit recognition. The digits comes under the 0 to 9. From the 0 to 9, if your new digit is either 0 or 1 or 2, not comes under all the classes. It comes under only one digit. That means 0 to 9 means that having 9 classes. From that classes you have to select only one classes. That is your multi-class classification. Multi-labeled classification means every input that can belong to multiple classes simultaneously. For example, if your news that comes under the political news as well as the economical news. If a news that not comes under only purely political, if the political and as well as the economics, that is your multi-labeled. The particular news that comes under the political news as well as the economical news. The next, binary. What is binary classification? Binary classification, it is also a supervised classification. It predicts one of two possible classes from the sample outputs, either 0 or 1, otherwise yes or no, true or false, spam, not spam, like that. That will select one class from among the two classes. Goal is learn decision boundary that separates the two classes. It find out the decision boundary that will separate two classes. The particular data set that will be classified two classes. Examples, email filtering. Email filtering means that is spam email or not spam email. Medical diagnosis means if you are a person having disease or not. The next, credit card is approval means if the person is eligible for credit card approval or rejected. The sentiment analysis. The sentiment analysis means the review is positive review or negative review. Like that, either positive or negative. That is your example of binary classifications. The process of binary classification, that will collect the data set. The data set, every data set that having label, every data set that having the label, input features that having the labels. That is the email labeled as either spam or not spam. Feature extraction, from the emails you have to extract some features like using word frequencies, like that. You have to extract the features. Every feature that comes under one label. Based on that labels, the classifier algorithms that will train the model. After training, you have to find out one pattern. Using that pattern, you have to predict the new email or a new disease prediction. All the things that will be predicted using the new patterns. The evaluation metrics of binary classification, not for binary classification, all the classifications that having the confusion matrix. That's the first thing. The confusion matrix means predicted positive, predicted negative. The next, actual positive and actual negative. Every data set that having some actual positive value and actual negative value. Likewise, the predicted output that having some predicted positive as well as the predicted negative values. Based on that, this is your confusion matrix. Based on this matrix also, you have to find out the metrics. The first one is accuracy. How to find out the accuracy? The accuracy, that means that is the overall measures of the correctness, overall correctness measures using the accuracy. Using this accuracy, you have to find out the prediction. That means true positive value and true negative value. You have to find out the true positive value or true negative value. Either it is true or false, that is correctly predicted. The other, all the things, true positive, false negative, false positive, true negative, all the things comes under the denominator. Okay, total, all the totals that will be divided true positive and true negatives. The true positive and true negative divided by the total of the predicted and the actual values. That is TP plus TN divided by TP plus TN plus FP plus Fn. In this example, the TP value is 50, TN value is 40, FB value is 5, Fn value is 5. You have to find out the accuracy using this formula. Accuracy is equal to true positive and true negative. True positive value is 50, true negative value is 40. The total 90 divided by all the 4 values. Total means that is 100. You have to get 90% of accuracy. The next matrix, the second metric is precision. The first one is accuracy, the next one is precision. Precision means in precision, that is a positive predictive value. Positive predictive values means comes under the positive predictive value. You are having the true positive and false positive. You having true positive and false positive. Both from the true positive and false positive, you have to predict the predicted positive values. How many predicted positive values? That is TP, and total TP plus false predictive. This is your precision. The likewise true positive rate, that is your recall. True positive rate. True positive rate means the true positive that having the in confusion matrix, true positive values that have true actual positive rate, you are having 2 values, this one and this one. That is a true positive and false negative. Likewise actual negative that having false positive and true negative. Using these 2, you have to find out the sensitivity and specificity. Okay, here you have to find out recall, that is sensitivity that find out the true positive rate. True positive rate, true positive divided by true positive plus false negative. The next specificity that comes under the second row, that is true negative divided by true negative plus false positive. Okay, these are the formulas. Fn score, that is equal to 2 into precision into recall divided by precision plus recall. The next one, balanced accuracy, that is where imbalance for imbalanced data. You have to find out the balance accuracy using the specificity, addition of specificity and the sensitivity divided by 2. Example for binary classification. In binary classification, the model predicts. These are the choices, multiple categories for each input, exactly one class out of many, one of 2 possible classes, here continuous value. In binary classification, that having 2 possible values only, from the 2 possible values it will find out 1 value. That is what your answer is one of 2 possible classes. The next one, binary classification using that will give the true positive value, false positive, false negative and true negative values. You have to find out the accuracy, precision and recall using the formulas. Accuracy is equal to true positive plus true negative divided by total. Precision means true positive divided by true positive plus false positive. Likewise, recall is equal to true positive divided by true positive plus false positive negative. Using these formulas, you have to apply these values and get the output. The same thing, binary classifier that having the set of values, given values, you have to find out the accuracy, precision, recall and F1 score using the particular formulas. The next one, multi-labeled classification. In multi-labeled classification, that having every instance or input that will be comes under the multiple classes simultaneously. For every input that comes under multiple classes. In binary classification, from the two possibility, you have to get only one possibility. But multi-label means it is having number of possibilities. From that possibilities, you have to get more than one possibility. Like if you okay, in movie prediction, if the particular movie that comes under the action and as well as the comedy and action as well as the drama, like comedy as well as the drama, if you have a particular movie that comes under two labels. Likewise, if your text, in your text categorization, the particular news that will be comes under the political news as well as the economical news. Medical diagnosis, a single patient that having more number of disease, that is your multi-labeled, the single input that comes under multiple labels. Process of multi-label. Likewise, binary classification algorithm, it will get some data set. Every data set that having the input as well as the labeled output, using that it will using some training algorithms, that means classifiers algorithms, it will predict or find out the new patterns. Based on that new pattern, you will get the output for the new inputs. Likewise, movie prediction, movie features, the plot summaries, actors, directors, etc. These are the features. Using these features, already the data set having this type of directors, they are giving this type of movies. Likewise, every features that will be labeled action movie or comedy movie, drama or romantic movie. Likewise, every features will be labeled. Using that labels, the model will be trained. From the training, it will get some predicted pattern. Using that pattern, you will give a news movie, means it will be predict if the or classify this movies comes under the drama and action movie. Likewise, you have it will classify. This is the process of multi-labeled classification. It is also having the confusion matrix. Likewise, the first metric is Hamming loss. It will find out the Hamming loss. The Hamming loss is equal to 1 divided by n into L. The summation of like this. N means number of samples, L means number of labels. Using this, you have to find out the Hamming loss. Likewise, the accuracy, precision, recall and F1 score, like binary classification. All this having some formulas. Using these formulas, you have to find out the values. It's an example, a multi-class classifier that having 3 samples and 4 labels. True labels means the data set that having the sample 1 that comes under the L1 and L2 label, sample 2 L2 label, sample 3 L1, L2, L4. From this true labels, the predicted labels, this is your true labels. Using these true labels, it will train and predict one pattern. Using using that pattern it will find out the predicted output for the new data set. That predicted output is for sample 1 it will predict L1 and L3, sample 2 L1 and L2 and sample 3 L2 and L4. Using this data set you have to find the Hamming loss. The Hamming loss it will be find out using the total prediction. Total prediction that will be calculated using the number of samples into number of labels, that is 12. That is your prediction, total predictions. Incorrect prediction for sample 1 0 errors, because sample 1 that is your actual, that is your true labels that having L1 and L3. Likewise predicted sample also having the L1 and L3. But the sample 2 here the true output is L2, but in predicted output is L1 and L2. It will predict the L2, but it extra predicted L1 also, so it is an 1 error. The next sample 3 L1, L2, L4, but sample 3 you have to find out L2 and L4. It missed out the L1, so it is 1 error. Total errors 2. Hamming loss is equal to 2 divided by 12, that is equal to 0.167. The next, multi-class classification. In multi-class classification, in binary classification, you have to find out only one options from two possibilities. But a multi-class means it will find out only one options from multiple classes, multiple possibilities. That is your multi-class classification. The output is exactly one class from the multiple categories. If the animals, you have to find out the animals. If the animals either cat or dog or horse, likewise it having multiple possibilities. From that multiple possibilities, if your given data is comes under the either cat or dog or horse, not comes under the more than one possibility. This is your multiple class classification. Example, digit recognition. The new coming digit is either 0 or 1. Likewise, either 0 to 1. Any of one possibility. Image classification. If your animal image comes under any of one animal category, either cat or dog or horse. Likewise, language. If your input language is either comes under the English or Tamil or French. Either one of multiple classes. Disease diagnosis means if you are finding the disease, the single person that he is having more number of disease. Example, it will images of the handwritten digits that will be extracted, each and every images that will be labeled, and training the algorithms. After the algorithm training, it will find out new pattern. Using that pattern, you have to find out the predicted value. This is also having the confusion matrix, accuracy formula, and as well as precision, recall, and F1 score. Using these formulas, you have to find out the accuracy, precision, recall. Example, in multi-class classification, these are the possible choices. In each instance belong to multiple categories. Each instance belongs to multiple categories. Each instance belongs to exactly one category out of many. In each instance belongs to multiple categories means that comes under the multi-label classification. In multi-class classification means each instance comes under exactly only one category among the multiple categories. This is your answer. This is your example problem. In an example problem, it having three classes, classes A, B, C. This is your confusion matrix. Here the actual prediction is this is your actual data, this is your predicted data for A, this is your predicted data for the B, this is your predicted data for the C. Okay, actual C and the predicted C, actual B and the predicted B, actual A and the predicted A. From this you have to find out the accuracy, recall for class B, macro average recall. Accuracy, that is your truly predicted. what are the values that are truly predicted. That means actual A and predicted A. This is your truly predicted. This is your truly predicted for B and truly predicted for C. For using this, you have to, this is your truly predicted divided by the total values. Likewise, you have to find out the recall, and recall of A, recall of C. Adding these three divided by 3 is equal to macro recall. Thank you. We will see it in the next class.